Hey, Super Rain, how's it going? I missed the beat drop. I missed the beat drop. That was just me being ridiculous. No, I wanted to check to see how the sound was doing versus background levels and stuff like that. So, let's drop it to 5 here. Okay. So, hope everybody's week has been going alright. We've been busy as usual around these parts. Unfortunately, I've got a lot of work to still do. But hey, why not? Gotta take a math break to do some math. So, yes, tonight's opening graphics here are so our opening graphics here are courtesy of one of my friends who that's not working. That's nope. Hang on. I'm just messing things up all over the place. All right. Let's see. There we go. Let's grab the other thing. Yeah. So the graphics here are cleaned up a bit thanks to one of my friends. He kind of helped me out with it. He's been doing graphic design and stuff like that for a long time. And I was like, here's my bid. And he was like, oh, God, that's really overpriced. And I was like, It's like, no. I figured that was an appropriate amount for all of the random Twitch stuff that was kind of needed. And, you know, anyway. So in the end, he was like, yeah, you probably want to just invest that money somewhere else. And I was like, seriously? Come on, this is so good. But he's got a lot of other stuff on his plate, so. All right, fair. But yeah, I absolutely love it. He cleaned it up very nicely, made a 3D model of everything up here. Just... Anyway, we'll get me back here and that back there. Okay. So that's going to be our new starting screen from now on, because yes, OBS does have undo. Or at least Control Z just happens to work. Which is good, because recentering all that after playing around with it was not going to be fun. Anyway. Alright, so let's take this. Gonna be heading out to... Yeah, so we haven't been doing a... sorry, yes, that was not what your question was. That I uploaded the graphics today. So he got back to me sometime between Sunday night and tonight. I have no idea when, because I have not even paid any attention at all. I have been grading papers basically obsessively for yesterday. Yeah, okay. Been grading papers obsessively for the last 36 hours. Still not done. Mostly because I keep watching Let's Plays of somebody. But anyway. Yeah, I did, and then 45 minutes of my audio got muted. So I was going to play Uh, it's okay. I was gonna play more Trail of Ayash, and then the bug that I reported, where my guy kind of, or my mission contact dropped through the planet, um, did not get teleported back up. So I'm wondering if there's some sort of like Skyrim-esque debug that I can just type into a console and pop. There he goes. But yep, I played about 20 minutes of Ayash and was like, yeah, okay, well, it's not going to work. So um, re redid the stream and put Heaven's Vault up there because I hadn't played it in a while, and I felt like, sure, why not? So there's there's something on the OST which is not cleared. So for whatever reason, this one song, or maybe like two or three songs, um, get get nixed. So I don't know what it is, like which one. I mean, I can find it easily enough. Um, just go back through. I didn't record it on my side. Hmm. Oh well. Anyway, so yeah, there's like two specific songs. It happened once, probably when I first started playing Heaven's Vault, and then just now. Probably in between, but I didn't notice. Hmm. I hadn't noticed that. It's interesting. Hmm. I guess that's fair. I haven't really been caring about uploading any of this stuff, so I've only been really recording like the actual math things that I've been doing, and not these like the like lessons, because whatever, it's fine. All right, so we've been lately doing. Oh, hang on, let's back up. There we go. Math starting soon. Replace. God, it's so big. I want that one. Arg. Why isn't this selecting? Okay, well this is fun. Oh, it's locked, that's why. You think I would notice like the big giant lock on the screen, but no, that's fine. There we go. Okay, well anyway. Yeah, lately we've been doing homework help for any random people who come in, and we've been doing this book, Mathematical Thinking, which I started doing. You probably were here for the tensor calc stuff, and I was like, all right, this is not going well. So I decided to go back and look at some of the basics. This is, I think this is from one of my colleagues who left, and he was retiring and was just like, here's all my books, and threw them to everybody. Rights to the font? What font? no. Oh, yeah, I should probably ask him. It could just be like a preloaded thing on his system, but I don't know. Yeah, that'd be interesting. Yes. Uh, George Lucas can come after my 31 cents that that I make on any of these streams, I'm sure. No, I mean it is a worthy question. I just never even, yeah, like I saw it and then I was like, just didn't cross my mind. That's fine. I'll just send that message over. I'm sure it's fine-ish. It's fine until you get a subpoena. Like that's fine, or a C and D, I suppose. They wouldn't send you a subpoena first thing. They'd send you a cease and desist. At least here in America. Other places they might just send guys to break your legs. All right. So last time we were talking about set theory. Why is this? Is that how we're playing this? Again? Really? So the tablet is apparently kind of finicky and wants its... Oh, right. The tablet wants its desktop center running. Something about proprietary software, whatever. Yeah, not ZF. This was just the basic stuff. So I was hoping to run through a bunch of random things and kind of uh, it's interesting. I kind of like this cursor with the like star shape to it. And when I start the really? Ugh, this is not cooperating. Whatever, it's fine. When I start up the Wacom tablet stuff, it starts or it switches it back to just like the mouse cursor, which, it's okay, I guess. But I think it makes way more sense to have something that looks almost like a writing utensil, or like the tip of a writing utensil. All right, proper notation. Uh-oh. Oh, that's why. I'm holding the pen upside down. Yeah, that'd do it. Right, 1-8 was the examples of all the counter set theory with the different numbers. I started explaining this to some of the other students who are in here looking for extra help, so that was fun. if anyone out there has any questions that they like answered, please feel free to interrupt. We're just having some chatting and yeah, yeah. I've asked you before, what is the actual meaning of that word? Just number. Okay. That's fun. Benji boy. Well, the good news is I've only been on for about 20 minutes, and it's just me and Superbrain like chatting, so it's fine. This was all from last week. So we were talking about set theory last time, trying to get into more of the formal definitions that are in our book here, and yeah, that's the other thing. Superbrain is. I don't think that the person involved in this particular book would come after me, but not specifically whole numbers or integers or something like that. Hmm. And Benji, you can always come back on video on demand, so no worries. I know you're not quite half the world away, but a long way away. Bertram, let's go! Yep, so actual the actual number sets that we've got going on down there going to be all those individual 3.141592.6 is about as far as I get, and because I just don't care. E though, I do know 2.718281828459045. So a few more decimal places. That one's easy because you got 2.7, 1828, 1828, and then right angle triangle 45, 95, 45, 90, 45. Oh, we'll get some inductions. Let's do that. That's way more fun. I mean, that's valid too. English has borrowed so many words from so many other languages. Like it's alrighty. 80's good. As long as you're still doing your homework and all that, then that'll raise it right up. I mean, I guess it depends on what level we're at. So, okay. So, inductive reasoning as a group. I've been doing this in my math literacy classes. So, you have inductive reasoning, which is slightly different, but we take very specific evidence and it leads to general conclusions. Most of the time, if we're not talking math, well, I mean, not like numerical stuff. So if we're talking like um, inductive reasoning in terms of like logic, then inductive conclusions. Usually can't be proved. We can only rate the strength of the argument. So, for instance, every Wednesday, Obi streams math. So, like, our proposition would be every Wednesday, Obi streams math. And our conclusion is that next Wednesday, Obi will stream math. Now, that might be a fairly sound argument in terms of like, well, you know, you've got, I'm using the wrong word. That may be a fairly strong inductive argument because every Wednesday that I can trace back, with the exception of like two, right? Every Wednesday for the last 2 years, every Wednesday for the last year and a little bit, with the exception of like 2 Wednesdays where I had to have time off, I have been streaming math. And so, if the conclusion is next Wednesday, I'm also going to be streaming math, this is a fairly strong argument. So as long as the premise here is actually true, then yeah, seems pretty strong. If premise 2 is always wearing red today, conclusion 2, right? Obi's wearing red today. Conclusion, Obi will wear red next stream. um, uh, 4. F-O-R-T. I say 4. Oh, ce n'est pas de problème. I can occasionally break into French. It's okay. Unfortunately, Superbrain, I might not be able to. I might not be able to pull as much German. Occasionally. Well, I can say it won't be a French stream because I will not embarrass myself or insult the French people so much. So, right, that's the thing is that like this is a fairly weak, so I'll say faible. Um, so this is going to be a fairly weak argument because again, it depends on my mood for that particular day. So it's not like every Wednesday I wear the same shirt. Or, I mean, I will say the fleece is pretty much here every week, unless it starts getting, warmer. I know last week it got pretty warm. So I ditched the fleece. It wasn't even in the room. Um, right. Could wear any particular color I feel like on that particular day. And it has no, there might be like a somewhat of a correlation. Oh, Canada. Wait. So you could probably understand me. I learned from, I think, six out of my seven French teachers were Français Canadian. So, because I lived in New Hampshire, and the other one was Haiti. So, so yeah, that last that last teacher from Haiti broke a lot of my bad habits that I picked up from the French Canadian women that I was learning from. No offense to them, they were wonderful people. I love them very dearly, but uh, as you probably know, there are some things that the Canadian French differs very wildly from the fr- fr- yeah Française French. Yes. Right, and that's the thing, Superbrain, is that I definitely am one of those people. I was originally going to, uh, I was originally going to major in linguistics, and I started in, so I started in physics, and I was going to go to astrophysics, which is really too bad that I didn't go for it because I'd be studying exoplanets right now. But, um, but nonetheless, it's really cool, and I really like it. Um, so then I was like, okay, I'm not going to be able to pass thermodynamics. There's like a 39% pass rate at our institution for thermodynamics. And I was like, that's probably not going to be me. So, yeah, I'd probably be doing either either theoretical um, either theoretical astrophysics, which would involve cosmology, so following in the footsteps of Hawking and Neil deGrasse Tyson and uh, God, Lawrence Krauss, Phil Plait, doing astronomy. No, that's not true. It's only indisputable within the axioms we have created. Okay, so mathematical induction is slightly different. This can be proven because, again, we have wonderful uh, axioms in this particular case which allow us to say, okay, this is going to be the same for all numbers. So what's the inductive conclusion in math specifically? So yeah. Oh my goodness. I had so much trouble just coming up with like logical arguments on the fly. Oh, it was so bad. So with mathematical induction, what we do is we say, okay, find a pattern and hypothesize. Yeah. That might be a Z in American. So anyway, yeah, it's a Z in American. All right, so when we find a pattern and hypothesize, our first step is going to be let so we're going to say But it's so easy. All right, so we say, okay, a sub n, the nth term of this particular sequence, is going to be something that looks like, uh, well, I'll do an easy one. So n times n plus 1 all over 2. So here the pattern is Cooler Yellow. How's it going? 18 bread. Welcome. What's this purple button do? I don't know. Oh man, which button are you pushing? Okay. No, not a raid, but Cooler Yellow, thank you very much for the support. Heyo. I will say, like, unless you're really desperate to, don't spend your money on me. All right, there are plenty of other streamers who actually need money. Um, but that being said, I will take Jeff Bezos's money any day of the week and twice on Sunday. So, so if anybody has a Twitch subscription that they feel like, why, thank you. Thank you for giving this. Oh, that one doesn't have a thing. I'll have to figure something out for that. Stream elements. Yeah, and I got to work out little emotes and stuff like that too. That was the other thing I wanted from my artist. Okay, anyway. So, if we just want to find the sum of the integers. Okay, so the sum of the integers. When we look at all of this stuff, we got n, which is the number we're on, and the sum of all n values, or all integers, I, going from 1 to n. All right, so if we've got 1, then we're stopping at 1. So it's just 1. If we've got 2, then we add 2 plus 1 is going to get us 3. If we go to 3, that's 1 plus 2 plus 3 is going to be 6. 1, 2, 3, 4 is going to get us 10. 5 is going to get us 15. 6 is going to get us 21. And so on and so forth. Ho ho! Cooler Yellow, what are you doing? Oh my goodness, thank you. This is absurd. Well, that does it. Yeah, fleece has to come off. All right. Thank you so very much, and welcome all of you wonderful people. 18 Bread, 2 Curbs, Bertram, and Accent. Welcome, and hope you enjoy your subs. And thank you, Cooler Yellow. That's very generous. Okay. So when we look at this, this ends up being, we already know this pattern. This is the triangular numbers. And yes, Superbrain, I will break out the triangle if I have to. I know, right? That's my monitor account. I feel kind of bad. All right, so these are our triangular numbers. So this keeps going up, and we want to find what is the pattern when we reach out to some n value that's way up here. Man, Gonna have to get those emotes quick. All right, so anyway, in this particular case, we say, well, if we have n equals 1, we're going to say, all right, plug it in. Let's see if this pattern holds. I know. So a sub 1 is going to be equal to 1 times 1 plus 1 over 2. So this is going to be 1 times 2, which is going to be 2 over 2, which is just 1. So again, this holds. The pattern that we found here holds. Like, oh, okay, that's pretty cool. All right, so then we assume that the pattern is going to hold for n. So 1, find out what happens when n equals 1. 2, assume that the pattern is going to hold for n. Whatever n you're going to use at the end, let's make sure that this pattern holds for all of them. Now, we could do this in terms of like, let's check 3, or sorry, let's check 2, 3, 4, 5, 6, 7, etc. Make sure all the ones that we can check work. But the problem is that at some point, we're going to have to say, okay, the pattern's good for these numbers, but what if it fails later on? What if it fails at like 50 billion? So we can plug in any one number we want, but it's going to take a really long time, in fact, infinitely long, to check every number. Unless we say, okay, it's not going to be, let's check every individual value. Instead, what we do is we say, assume that the pattern holds for some n value. N can be as far back as we want it to go, or it could be the number 2, or anything else. Or n could be literally the number 1, right? N is 1. We showed that it works for that, so then we're going to assume that it works for any number n, and then we have to prove, and this is the hard bit, prove that it holds for n plus 1. So, we're going to look at this, we're going to say, okay, we're going to assume the pattern holds for some n value, which at the first part is going to literally be 1. And then if we prove that it works for n plus 1, that means that it works for 2. And if 2 is n, then n plus 1 is 3. And if 3 is n, then n plus 1 is 4. And so on and so forth. And this proves it infinitely. It proves it for any possible number n that you could ever choose. This is sort of like I call this bootstrapping, but I don't know. It sort of works. So again, we know it works for 1 or some low value. It doesn't matter what it is. So in this case, we want to know what the pattern is starting from 1 and then going all the way up to as far as we want. So we let n be the lowest value that we want to check, which in this case is 1. Then we say, okay, let it be generalized to n, and then prove that it works for n plus 1. So again, n was 1, so n plus 1 is 2. Then we shift it back and say n is 2, it works, see? And then n plus 1 is 3. And then shift back 3, n plus, 3 is n now because 3 works, and n plus 1 is 4. Right. Yeah, and that's the other thing, is you want it to start at whatever your lowest value is, and then start working up. And in theory, you could also do this the other direction if you wanted it to go negative instead. Start with your highest value and then go negative forever. But we don't typically do stuff like that. Because again, most of the time we will index on that's what this I is here, we will index on positive whole numbers. And just say, oh, it's the first number, it's the second number, it's the third number, etc. Okay. So for this one, we assume, all right, we show that it works for a equals, nope, we show that it works for n equals 1. Then we assume that the pattern is going to hold for n. So a sub n equals n times n plus 1 over 2. Again, we just assume that that's going to work. Then we have to show that based on that, a sub n equals n times n plus 1 over 2. We now have to add the next number. So if we add n plus 1 to both sides, here, this is going to be, okay, a sub n was the sum of all integers up to that point. Negative plasma. Meowdy. Good evening. Welcome to N Simplex Pachinko. I am Obi-Wan Pez, your host for all things hopefully mathematical. So, we do, we do math streams on Wednesdays and gaming streams on Fridays, and hope you can have some fun hanging out here. So, welcome. All right, so a sub n is the sum of all numbers that goes from 1 to n. So here, this is 1 plus 2 plus 3 all the way up to plus n. And now we've just added n plus 1. And negative plasma, if you have any questions specifically about mathematics, any mathematics, let me know and pop it in the chat and I will get to it fairly shortly. So we've got this n plus 1 here, which now means that the whole left side is going to be a sub n plus 1, because it's the sum of all numbers 1 through n plus 1. And then on the right, we've got to actually do some algebra here. So this is going to be n times n plus 1 all over 2, plus n plus 1 is 2 times n plus 1 over 2. And now we can combine the fractions. So here, if we notice, n plus 1 can be factored out from those. So n plus 1 as a factor is going to leave behind n from here and 2 from here, and they're added. So n plus 2. This is all over 2. This is now n plus 1 out front, and parentheses n plus 1 inside the parentheses, all over 2. This is a sub n plus 1. So now we've just shown that if we just plug in n plus 1 into all of these places here, we end up getting this same thing. So our formula is going to work for any value n plus 1, which is going to be 1 more than some proven value, which again can be 1. And then, since we just got the value for n plus 1 to be 2, then we let n be 2, and n plus 1 is now going to be 3, and then continue off infinitely. So this is proven by induction. This particular pattern here, the sum of all integers, can be proven by induction. It's a wonderful little hint that we can get. All right, there's a whole section on this I know somewhere. Question is where? Ooh. Aha, Principle of Induction, Chapter 3. So not exactly. The goal of this particular thing, the goal here for the sum of the integers was to prove that the sum of all integers going from I equals 1 to n is going to be equal to n times n plus 1 all over 2. That the sum of all integers up through n, or the sum of the first n integers, is going to be the product of that last number plus one more than it divided by 2. This ends up being a really nice proof that Carl Friedrich Gauss did back in the 1800s. When he was in grade school, he figured this out. His teacher was kind of pissed off with him and was just like, no, just add up all the numbers 1 to 100. I can't deal with you right now because, he's bored. What was that? What'd I screw up? Friedrich? Plasma, that is a great emote. Now I understand the Meowdy much more. No, it's fine. Give me an excuse to eat something. Okay, so... Ayo. Oh, great. You've been hanging out on video on demand? So Gauss figured this pattern out because his teacher had said, okay, just add up all the numbers 1 to 100. Well, you can imagine after starting a few of these, he was just like, okay, clearly you just want to distract me, and there must be an easier way to do this. So eventually, he figured out that, well, we need to do some sort of addition. And we're going to be doing addition preferably of like the same number over and over and over again. So we can turn this tedious addition into multiplication. It'd be much easier. So, Megalomorph Discord, yep. Yeah, speaking of, I forgot today. Oh well. Well, thank you for coming in anyway. Yeah, so it might be apocryphal. But I think like he was the one who told it. So there's a like reasonable chance that it's real. So what he did was, or allegedly, what he did was he said, okay, let's take this and let's take the number line and duplicate it. And line these up. Because all of these numbers add up to 101 plus 101 plus 101 plus 101. And then how many of them are there? Well, there's 1 through 100. So that's 100 numbers. So 100, 101s, and then there are 2 lines that we're adding, so we only want half of them. So this number comes out to be, 5,050. And after about 5 minutes, Gauss went up to his teacher, allegedly, and said, the teacher said, yes, you have a question. And he said, no, I'm done. So I teach at a 2-year college in the middle Atlantic of the United States. So it is a Interesting mix of students. We've got basically everybody from like basic algebra all the way up through differential equations. So usually second year of college, university. It is labeled a community college, yes. Yes, in the middle of the Atlantic Ocean. Yes. Sorry, mid-Atlantic region of the United States. Oh man, this is gonna be a good day. All right. Woo! Nice. All right. Yep. No, no, no. That's fine. I mean, you don't know that. It's. Mm-hmm. It'd be really funny if you were the same guy who played Ingress with me. On my campus, but no, probably not. No, if you're university, then yeah, we only have 2 year students. I used to. I got kind of fed up with it, and they got a whole lot of new things going on that like I have not been paying attention to. But yeah, I didn't have that kind of time. Although during the pandemic, it would have kept me walking a bit more, which I really could have used. Hmm. Yep. I think he was IT or something anyway, not. Who's it? Yeah, not computer science. I think it was IT. Anyway. Yeah, I kind of feel the same way. Um, except I made time on Fridays. I watched a couple more people play Outer Wilds, and I will stand by my statement that I pretty much am always going to watch somebody who is playing Outer Wilds anytime that I happen to get there. It's honestly like watching people trying to solve, complex math problems and stuff like that. It's you get into this mode in this particular game, and there's just, you know, what's the thought process? Let's watch how people work through all the different crazy puzzles that are in there. Um, oh goodness. So yeah, had a couple of watched a couple of streamers' old videos on them playing Outer Wilds. Had a good couple of teary moments there because oh my god, it's such a great game. It's always great when I get myself slightly teary just before I have to go teach class. So it's great. What's the matter with you? Nothing. It happened at my old school. That was bad. It was just before homeroom, and I finished my copy of The Salmon of Doubt. I think I'm gonna put it back. Unless that's it. Yeah, that's it. Yeah, The Salmon of Doubt. Douglas Adams' posthumous work. Like 2/3 of the book It's really cool. Two-thirds of this book is just like random letters and memoirs and like basically like Douglas Adams' writing practice of just him being funny and just trying out different things. He's got like letters to the editor back in, letters to the editor that he wrote as a kid. There's all sorts of stuff. It's really cool. And then the last third of the book, give or take, is what he had, like the rough, very rough um, notes on a new Dirk Gently story that he was working on, which he told somebody, well, actually, it's kind of looking more like a Hitchhiker book. And so it never developed. And then the last thing in the book is an epilogue written by his best friend at the time, Richard Dawkins, um, which was like the it is a keening lament. So he tells the story of when he found out, and then what they were all going to do. His reaction to the news that Douglas Adams had died at 49 years old. Um, and it's just crazy to think about it. uh, so yeah, I finished that last line of Richard Dawkins saying that stuff about 5 minutes before homeroom, and I'm just like, everybody else is looking at me like, Jesus, man, are you all right? Let's calm down. I'm like, no. Oh, it was great. All right, so yeah, plasma. I did not get a PhD. I have a Master's of Science in Applied and Computational Mathematics. Oh, Superbrain's gonna look that one up. I see you. Yeah, so it was applied math. Um, it's actually it. I wear the sweatshirt all the time. I got that one at the Johns Hopkins Applied Physics Lab. Um, they had a nice program to do. Yeah, so they had a program at the Johns Hopkins Applied Physics Lab, which was like up the street from where I used to live. So it was pretty nice. Um, so pure math, I don't actually know, but uh, I'm guessing that I would have had to take topology, math analysis. Let's see, what else do I have back here? Not much. I think I stole most of the books that my spouse had back here. Um, I probably probably. Well, like I said, we used to live there. So it was a great, yeah, it was a great place to just go and hang out a couple of times a week and really, you know, talk math and talk shop with the people who were there. I had a couple of problems with the teachers, specifically that they were not teachers. Um, they were math professionals, which is fine. But at the same time, I, a teacher, am sitting in the class going, "Oh, don't do that. Don't no, don't read from the book. Don't just do problems straight from the book. I could have sat at home and done this." So, I mean, that's pretty much anywhere really. But yeah, it's like they didn't give them teacher training. They just were like, "Here you go, here, teach a class." Which granted, some full-time professors are just the same as that. I will grant you. But many of them hone their craft over, years and decades of training themselves. Um, these guys, yeah, they did all right, but pretty much. So yeah, I wear my Hopkins sweatshirt all the time. People are like, "Oh my God, you went to Johns Hopkins. You must be so amazing." I'm like, "No." Like I did all right, but I'm much much better off after I got out and like started actually using that stuff. Because this was another thing that kind of bothered me. Like I went to state school. I went to the University of New Hampshire. This is, for my undergrad stuff. And I was in math education, and I wasn't a really great student. I was okay. I was much better than the random people who partied all the time. Um, but I was not like a super great, super studious student. Um, but as soon as I left and I got out, like, into the workplace and started thinking about stuff and didn't have to do something for an assignment, but I would just do math because that's what I wanted to do. I started working on lesson plans before I got a job, right? So, like, let's just, in theory, let's work out. I had to take a couple of classes in reading in the content area. So, how can we read your books better? And pretty early on in the first semester of this two-semester course, I was like, I get it now. We need to figure out how to communicate this better. So, like, we need to teach students how to read the textbook because A, math textbooks are way different than anything else in any other content area, and B, um, they're kind of thick, like in terms of just, you know, they're the content is densely packed in this stuff. And I know, and I'm sure all of you can attest, what do you do when you get a textbook and you get an assignment to do that thing? You look at the examples and you do some, and that's about it, right? Am I calling you all out? I'm calling myself out. It was pretty awful. And I was like, the first couple of weeks, I went to this class and I was like, this is such a waste of time. I don't need to learn how to read in the content area. This is silly. And then, about, like I said, 3 weeks in, we did this thing, and I was like, oh, that's what I'm missing. And I finally figured it out. Like, how can I read the textbook first of all, and then how can I translate that for the students? So, like, pretty much all the time, I've set up a whole bunch of. Um, I think next semester I'm gonna set up reading assignments for my students. Like, actually do set up reading assignments and be like, you need to actually read the book, you need to actually read this stuff, and actually come up with answers to my questions. And it's not just going to be math stuff. It's going to be like, so we studied, yeah, essays. Yeah, yeah, that's true. It is much easier. These days, we're using a lot of open source, so the stuff on OpenStax. So, oh yeah, I failed a midterm exam one time in my English class because I literally did not do the work. I didn't do the reading, and she asked a like very explicit question about the reading, and I BS'd my way through it, and I didn't fail. I got a D. But yeah, I was pretty close to. But the problem was, and I figured this out by reading Douglas Adams. that I literally could not read William Faulkner. Well, Bertram, that all depends. If you're planning on being a YouTuber and like writing essays about stuff, then guess what? I gotta say, watch one video essay, just one, from I'm gonna go with Jacob Geller. He does yeah, yeah. Watch one video essay from Jacob Geller. Your pick. My favorites so far have been Outer Wilds, which is no surprise because I love the game. And if you haven't played the game yet, you definitely need to play that game. It is basically an escape room in video game format. If you don't like that idea, fine. Just you can watch somebody else play it or whatever. But it is an experience to be had, and I'm trying to convince my spouse that she needs to play it. So I would like to, on off days, basically be sitting on the couch and just like not guiding, but be there in case she needs to ask questions. But anyway, Jacob Geller, right? My favorite ones are Outer Wilds. Um, oh, there was one with Wolfenstein and Judaism. Wolfenstein, Judaism, and Whiteness. That was an amazing essay. I loved it. And I wasn't like a big fan of Wolfenstein, any of them. But it is an essay. If you wrote that, if you wrote that down in a non-video format, I guarantee these people would win essay contests. I mean, there's a lot of research that goes into some of that stuff, and it's pretty awesome. But I'm saying like beyond go if you go beyond school, right? You want to be able to effectively communicate your position and argue for and against certain things. So you want to explain what your thought process is and why you're getting there. If you can correctly, you know, throw out an essay that has stuff, you can convince people of a lot of stuff. That's I mean, he's doing an immense amount of work just convincing other people to play some of the games he's done essays on. Kind of amazing. All right, now why isn't my app working? That's ridiculous. All right, well, we'll just have to deal with that. Well, yeah. So don't come. So this is the other thing that I didn't realize until much later. Well, yes, you're being told that you can't graduate unless you can convince somebody that you're worthy of it. Ugh, yeah, that's rough. And that presents an unfair bias because if it's like I there's a couple of things, right? So on the one hand, you've got the fact that yeah, if you work a certain job, certain types of jobs, you need to be able to get someplace on time no matter what. So like if you live far away, that just means you need to leave earlier or need to get up earlier or whatever. And that sucks. And I absolutely hate that kind of thing, especially, and it's a very biased statement to pass judgment on, to say like, no, you just need to leave earlier. Like, the not always. It doesn't always work that way. And then at the same time, on the other hand, you know, like we're living in a much more flexible society these days. Why not just be able to have that available online or whatever, and just be like, hey, stuff's online. If you're late, just check it out. And like that's pretty much how we do it in our college level. Is just like, yeah, you know, look, you're in class, you're going to get the explanation. You can ask questions about stuff. It's much more interactive and it's much more worthwhile. But if you're not going to be here, I take pictures of all of my boards and post them in the class, you know, learning management system. So there's a nice little place for pages. You create a page and I dump all of my, whatever, JPEGs or whatever they are. I dump all the JPEGs into the files and then add them onto these pages. What's that? Yeah. So, I mean, to your point, Bertram, I also had to write a promotion project recently in order to get myself from my current level, which is, so we have like a probationary level, which basically you're always in that probationary level if you've never worked someplace for a long period of time, like a full-time professorship somewhere. And then you have level one, which you can enter directly if you have been like associate professor or assistant professor or whatever they call it at their particular institution. Um, and then you've got level two, which is what I'm going for, which again, you have to be at your institution, pass your um, probationary period, and then make it to the next level. So you've got to do like a little project there, which is like basically just write up what you learned over the past 3 years. Would you learn? And again, convince people. So that project, it was after my first 3 years of working there, and then they're like, okay, now you're going to start working on a promotion project for the next level. And I was like, that's kind of quick, but all right. So I took my particular class and I was like, hey, this other thing that this other lady's doing in anthropology, I really like the way that she's doing it, and I'd like to adapt that to try to make it work for my class. And it most certainly did not work, but I spent 8 years of my life on this. Um, it's only supposed to be three, but after three, I was like, I have insufficient data and it's not working the way I want it to. So my boss was like, okay, let's reframe it and resubmit it. And then you've got another, like year or two to do it. And it worked out okay. I spent another three on it, another full 3 years on it. And then the last 2 years, I actually had the write up done in March of 2020. Submitted it, and then my boss was like, it's not, it doesn't, this isn't going to work. So we need to polish it. We're going to spend the year, make sure it works, and then get it back submitted next year. So in 2021, he was like, all right, let's go. And then they were like, yeah, we're not doing promotions this year. I'm like, okay. So then he was like, no, no, this is good. We got another year to polish it, make sure we got everything in ducks in a row. Yep, 18 bread. See you later. Thank you very much for coming. Rainy Guppy. Great name. Welcome in. I know some stuff about game theory, not a whole lot, but I do have a book at my office. Um, no, it wasn't him though. It wasn't him. So he was, and and my other boss before him, she was fine. He was fine. The problem was that the vice president level just like laid down the thing that was like, we're not doing promotions this year because it's like pandemic and we're all in a panic and all this stuff. And we were also losing enrollment. So they're like, we don't have money for this right now, so just give us another year. All right, let's give it a shot. I may have to give you a problem that is similar to, but legally distinct from the one you were going to give me. Who? Aha. Okay. Yep. Thank you for the follow. Well, it played. Didn't come over the monitor. That's a little weird. Okay. Mm-hmm. So this is all going to be normalized based on the congestion at 1. Then C2 is going to be this value here. C3 is going to be this value here. It's based on X commuters taking each individual route with M total commuters. If everybody picks one specific route, then yeah, it's going to be a little bit of a messed up situation. Alright, if some route is not chosen by any player, this creates unbearable satisfaction to everyone, so unlike other partitions of players, the result of one route does affect the rest in this case. Each of the questions below for the special cases m equals 6, 9, nice. Assuming that each player wants to minimize the congestion of the route she has chosen, find all pure Nash equilibria. Okay, interesting. Assuming that the quality of an outcome is measured using utilitarian objective Determine the price of anarchy and the price of stability. Oh man. Yeah. This is a little bit above my pay grade, but third year math major. Yeah. Game theory is one that I never actually took, but I bought a book of it from some place. I don't even remember. I mean, I already got one, but thank you. Right, so x is going to be between 1 and m minus 1 so that it doesn't cause infinite congestion and also does not cause unbearable unsatisfaction. Dissatisfaction, really, but okay. Whew. Set up the conditions to prove each line is a pure Nash equilibrium. Okay. Yeah, okay. Misakide, how's it going? Okay. So, yeah, I don't remember enough of this, but let's go with because I want to be a punk. Mm, all right. Is this does this particularly matter? If I change it, is it going to screw everything up? Probably. All right. How do we incur the performance penalty if a path is not chosen, and can that condition be written into an equation? So if a path is completely not chosen, I feel like we should have a utility function. Now, that doesn't necessarily mean that there is one, but a utility function would be nice. So if it was like, the so all it just means is that um, the people going down the congested path would be pining for the fjords going in the other direction, which has nobody on it. They'd be like, "Oh, why didn't I go that way?" So, so if we have a utility function, we'd want something like the number of people on a given path should be like x sub I divided by c sub I. Now, this doesn't mean that this is going to work at all. I'm just spitballing here. No, no, that's going to be. These are both bad things. So they're going to be. They would both be inversely proportional to the utility function as a whole. So if we wanted any individual utility to be described, it would be somewhat proportional to, inversely proportional to the number of people on that path and the congestion based on that number of people. Although x could just be already used in the c part of the function, so we may not need it at all. Now this is, like I said, this is just me spitballing here. So if we see this, so answer the questions below for the special cases that m is equal to 6 or 9. Now, you wouldn't want to have to do all of the different possibilities, but right, C1 of any x value is going to be 1. C2 of x is going to be 3x over 6 or x over 2. C3 of x is going to be 1/2 plus 3x over 2 times 6 or 12. That's going to get rid of that, so that's 2 with a 1 here. This is going to be 2 halves, or 2 fourths. This is 1/4 x. So this is going to be x plus 2 all over 4. Variable unsatisfaction just sets up the conditions to choose the single path. From there you have to prove that that path is pure Nash equilibrium. Okay. All right, and technically, this should be like x1, x2, and x3. But I'm only being nitpicky because basically I've got nothing else. Oops, that's not x1. But, okay, so if you're going to say it's a pure Nash equilibrium, then you're saying that everybody is going to go on each of the 3 paths in 3 different cases. And then showing that this is terrible, right? So specifically for m equals 6, C1 of 6 is still going to be equal to 1. C2 of, no, 0 would be, in that case, it's going to be 0. And C3 of 0 is going to end up being, interestingly enough, a half. Not sure how that happens, but cool. I guess local traffic. So then C1 of 0 is going to be 1 when C2 of 6 is going to be 6 over 2 is 3. And then C3 of 0 is going to be 1/2 again. So then C1 of 0 is going to be 1. C2 of 0 is going to be 0. And C3 of 0, nope, 6. Take it in turn. Is equal to 6 plus 2 is 8 over 4 is 2. Maybe. Oh, okay. So essentially linear programming, where you've got like I used to do something like this. Only it's in 3 dimensions now. So any set is going to have a value that's going to be somewhere in this quadrilateral. Now, this is in 2 dimensions, so it's not actually analogous, or it's analogous, but it's not the same. So the way we used to do it in our other class was you'd get a utility function. Now, this one doesn't have a utility function, but that's fine. You get a utility function which would measure, like, what's the best value for whatever you've got for your 2 variables. So this is like x1 and x2. Let's not do that. This would be like, that's awful. Y1 and Y2. So we'd say on or in variables y1 and y2, you'd pick a point, and then you could plug it into the utility function. But it would end up that the only points that you had to actually worry about, for this anyway, were the endpoints. All of our mixed cases, where we ended up having like maximal and minimal values for our utility function. And you could actually prove it using some calculus, that the utility function was maximized or minimized at all 4 of these points. Whether that be maximized or minimized for that particular variable or the whole situation. And then you had to evaluate at all 4 of them to see which one worked. Now, the stuff in the middle didn't actually matter at all, because, again, you're trying to maximize and minimize, so it has to be somewhere along the outside. Right. So in this particular case, we're saying, okay, this is going to be maximized for all 3 individually. So we get maximized congestion there. And then we can show that we have to do some sort of combination of those in order to get a minimized overall congestion. Okay. Be right back. 1 sec. then so from there, so there's got to be a way to pick a better combination. Hmm. Like you can define each one based on the other stuff, but that's not necessarily going to help. Four m over 2m, just going to get 2 minus 3 x1 over 2m minus 3 x2 over 2m I'm just playing at this point, so. Yeah, could happen. Alright, so that's going to be 3 minus 3 x1 over m minus 3 x3 over m. I wouldn't recommend this, but another fun thing you could do is set these to be color coded to RG and B. Make them a vector. And then use your x1, x2, x3 as your position coordinates. Could do something like this in MATLAB potentially. And coordinate all of the individual points to be a certain color based on the RGB values or values of C1, C2, C3 as a vector or as a normalized vector. I don't know where that's going to get you, but yeah.